Hi, welcome to the lesson on inequalities. Today I want to talk about linear inequalities and quadratic inequalities. Now, unlike the previous video where I stated that equations are rarely asked as they are, where they ask you to solve for x or solve for y or solve for an unknown variable, with inequalities this may be different. Inequalities can be asked in a variety of ways. They can ask you to just solve an inequality because it is much harder to test an inequality than it is to test for equations. So if you were to take the long method with it, it would not be worthwhile, especially for quadratic inequalities. But what is the major difference between inequalities and equations? Well, an inequality is a mathematical statement that describes the relationship between two expressions, whereas an equation is a mathematical statement that describes or that rather equates two statements together or two expressions together. And with an equation, there's always a limited number of solutions, but this is not the case with inequalities. With inequalities, there's always a range or a broad number of solutions where the solutions can range from a limited area or from a certain point towards infinity or negative infinity. Now, to actually visualize this, let's use a simple example such as x plus 2 is greater than 3. So for what values of x will this inequality be true? And what we are concerned with is the values that we can assign to x. What are the values that we can assign to x such that this inequality remains true? Let's try and substitute 1 for x. We would have 1 plus 2, which would give us 3. But 3 is equal to 3. It is not greater than 3. So that would be incorrect. If we try substituting 0 for x, we would have 0 plus 2. But 0 plus 2 would give us 2. And 2 is less than 3, which would not be true. So when we solve inequalities, we use the same methods that we use when solving for equations. We simply move 2 to the other side or subtract 2 on both sides to get that x should be greater than 1. This means that x cannot be 1, but x can be any value that is greater than 1. So to put that into perspective, x can be any value between 1 and infinity, like that. If we were to visualize this, then we would have our x-axis, and 1 would be our critical point, and we would have our function like that. And this line would represent 3, and we see our line for every x value that is greater than 3. So we'd have something like this. This is your x-axis, this is your y-axis. For any x value that is greater than 1, our, let's say this is 1, 2, 3, 4. Any x value that is greater than 1 corresponds to a y value that is greater than 3, which is what we are looking for. We were concerned with finding this critical point, this 1 point over here. Therefore, any value that is greater than 1 satisfies this condition. This is a linear inequality. We're only concerned with one critical point, and we evaluate it at that point, before that point, and after that point to find the region that satisfies our answer. Or we can just solve it as it is using algebraic methods. Now we can move on to quadratic inequalities, which tend to pose a greater challenge. So if we have something like we had before, so let's say x squared, let's say now minus 3x, and then we're going to say minus 4 is less than 0, or let's say take 4 to the other side, greater than 4, like that. So this is a format in which you might find a quadratic inequality in, and the steps that you should take when solving for this is simple. just get it into the trinomial format. So take 4 to the other side and then leave 0 on the other side, like that. Then what you want to do is you want to open up your two brackets and you want to put x as placeholders over here, and then find the factors, which would be minus 3 and plus 1, and then you say this needs to be greater than 0. Then what you want to do is you want to have a critical value. At this point we usually find what our answers are, but what our answers usually are in equations is referred to as critical values in inequalities. So our critical value here would be 3, and our other critical value would be minus 1. Critical values are basically values that would make our equation or expression 0. And then what we do is we draw our x-axis. We don't really need to have a y-axis, but for the sake of normalcy, I'll just put 1 over here. Although this is not a critical point, it is critical for the explanation. Then what we're going to do is we're going to mark our points. So we have minus 1 and 3. So that will be minus 1 and that will be 3. Then we're going to draw a parabola, since what we're working with is a quadratic function. With linear functions or linear inequalities, we draw a straight line to indicate the regions. But here we need 2 lines, or rather 2 points that we need to join. Therefore, now we'll evaluate what the question is actually asking for. And in case you're wondering, how did I know to draw it facing this way and not that way? For that, you look at the value of a. If a is positive, then you draw it as a smiling shape, so like that. Let me try that again. Something like this. Then what we want to do now is we want to evaluate it for when it is greater than 0. So what does this mean? This is basically saying if this is a function, let's call it f, we're looking for when f is greater than 0. F is otherwise known as y. We're looking for when y is greater than 0. So at the x-axis, we know that y is equal to 0. Below the x-axis, we know that y is less than 0. Above the x-axis, we know that y is greater than 0. So this is the region we are interested in. And we have to find the x values that make this true. So these are all of these x values and all of these x values, because we can see all of these x values map to y values that are greater than 0, which is what we are looking for. Therefore, when you write your answer down, you say x has to be less than minus 1, or x has to be greater than 3. We don't include any of the answers between minus 1 and 3 because these values over here map to values that are negative, and that's not what we're looking for. We're not looking to satisfy this condition. Therefore, we don't include any values between minus 1 and 3 in our answer. And that's about it. That's as much as you need to know for inequalities. Also, be able to convert word problems into inequalities if need be. Be able to solve inequalities involving fractions, or inequalities involving logarithms, which we will discuss in the lessons to come.